Okay, this is going on page 40. No, yes? Shoot, I already forgot. Yes, 40. All right, going on page 40 when we're done. Operations with functions. Okay? Oh, bless you. Goodness. Enthusiasm. All right, so functions can be combined using addition, subtraction, multiplication, and division. So we're combining them. This is not composition of functions. That's coming Monday. But we're combining just with addition, subtraction, multiplication, and division. And it can be notated differently than this. This is the way we're going to look at it right now, f plus g of x. Okay, but that should be off right now. I will take that just like I will take your phone. So put that away. So f plus g of x would be f of x plus g of x. That's another way to look at it. Right? And then f minus g of x could be f of x minus g of x. Multiplication, f of x times g of x. And then division, f of x divided by g of x. Okay. So this is the sum, this is the difference, this is the what? Product, this is the quotient. Okay. So those are words that are important to know because we're going to talk about that right here. And if you don't know what it means, then that's going to be a problem. All right, so the domain of the new function, okay, so the domain of the new function is the intersection of the combined functions. The domain is further restricted with the quotient function to exclude values in which g of x equals 0, okay? Intersection. It's not a passing through of things. Intersection is what two things have in common. So when you're looking at sets of numbers, we're looking at what they have in common. So we need to do some domain investigation before we start. We need to figure out what the domain of all of our answers are before we even find them. So we look first at what the domain of the actual functions are. And we are going to do these not in interval notation. I did all of mine when I worked it out all in interval notation, but some of them it gets to be kind of a lot. So we're going to use set notation and some inequality notation here, which simplifies it a little bit. Still with your functions and the graphing that we've been doing, all that should be an interval. But for this and for piecewise, we're going to, go ahead and do the other one as well, because you should be able to go back and forth and do the different ones anyway. So what could we say? What's the domain here? All real numbers. So these are all real numbers. And the domain here, what? All real numbers. Okay, so the intersection of the two domains would be what? All real numbers, because that's what they have in common, everything, right? So then I move on and to substitute this in. F plus g of x is going to be f of x, which is x squared plus x plus 3x minus 1. And that's pretty simple, yes? That means that f plus g of x is going to equal x squared plus 4x minus 1. The domain would be all real numbers. Yes? Awesome. All right, so then f minus g of x is going to be x squared plus x minus 3x minus 1. Did I substitute that correctly? No. What do I need to do? Parentheses, yes. Parentheses. If you were thinking, no, that should be plus 1, no. First step, 0 work, you substitute it in, which means there should be parentheses there. It didn't matter over there, but truly, anytime you substitute in anything that has more than one term, you should put parentheses around that expression. Even the first one, just in case, so you don't mess things up, even though it doesn't have to be there. So then we have f minus g of x is equal to x squared minus 2x, then what? Plus 1. And my domain is all real numbers. Everybody okay with that? So then f times g of x is going to be x squared plus x times 3x minus 1. Did I substitute that correctly? No. In this case, both sets of parentheses matter, right? Because this and this are two completely different things. Then I need to actually multiply that. So x squared and 3x is 3x cubed, then minus x squared plus 3x squared minus x. So f times g of x is 3x cubed plus 2x squared minus x. And my domain is what? All real numbers. So if I go back up here and read what this says, it says the domain of the new function is the intersection of the combined functions, so we're good on all those. Then it says the domain is further restricted with the quotient function to exclude the values in which g of x is equal to 0. You have to figure that out beforehand, because is it possible when I substitute things in that things could cancel out? Yes, and if I don't look at the domain before that, I might miss something that I don't get to actually use. So before I even do that, I know for the quotient that g of x cannot equal 0. So that means that 3x minus 1 cannot equal 0. So I got to figure out what x can equal, right? So 3x cannot equal 1. So x cannot equal what? 1/3. And that wouldn't necessarily be the only part of my domain. That's a further restriction. Now, it wasn't restricted at all, but a further restriction. So then I substitute this stuff in. F of x is x squared plus x divided by g of x, which is 3x minus 1. Can I cancel these x's out? No. I will kick you out of my room. No. Okay? You should not be doing those things anymore. But it's possible that we could cancel something out with something like this, right? And if I could, maybe the numerator, maybe to try and figure out what could I do in the numerator. I could factor out the GCF. I don't have to actually do that, because you should be at the point where you can look at that, and when you factor it out, you know you're going to be left with x times x plus 1, and that's not going to cancel out, so you don't have to actually go any further. But always make sure that you're looking at that so you know what to expect, okay? So can we reduce this at all? No, we can't. So this is equal to f over g of x in my domain. All right, so in order to write it like that, now I could write it in interval notation. I could write it in inequality notation. I kind of like that. So that's set notation, which means I would have to say a set of all x's such that x cannot equal 1/3. You can also see that written where it would say x such that x is an element of the real numbers and x cannot equal 1/3, but you kind of assume, and that's when you're only dealing in that set of numbers, real numbers anyway, that's part of it. Okay, so we're good. All right, questions? All right, this should all be a review, but even though you've done this, you may not have done it with some of the types of functions that we're using, so I want to make sure that we go through all these so that we're not doing weird things. Okay, what is my domain here? All real numbers. Is this all real numbers? No. What has to be true about x? Greater than or equal to 0. It's okay to be 0, right? So the intersection of these two domains is what? This right here, right? That's what they have in common. This is real numbers that are greater than or equal to 0, and this lives inside of this set, but this is the intersection, because both of these have this right here in common. So then f plus g would be x squared plus 9 plus the square root of x. Then we should put this in descending exponent values. So that would give me x squared plus the square root of x plus 9. Then my domain is x is greater than or equal to 0. Okay, everybody okay with that? All right, so then f minus g, that's going to give me x squared plus 9 minus the square root of x. So f minus g of x is x squared minus the square root of x plus 9. And my domain is what? X has to be greater than or equal to 0. All right. F times g of x. We're going to get x squared plus 9 times the square root of x. Did I substitute that correctly? No, I need these parentheses here, right? All right, so when I distribute this, am I going to put x squared times the square root of x? Or what should I do here? What should I be using? Good. I need to be using my rational exponents. So this really is x squared plus 9 times x to the 1/2 power. And when I multiply those x's, I do what with the exponents? Add them. So can I say that it's x to the 2.5 power? No. See, I think that's funny. And how many times have I told you no mixed numbers? And you're like, I would never write that. Well, yes, that's why I've been preaching to you forever. No mixed numbers. You don't put x to the 2.5 power, right? It would be x to the what? 5/2. So x to the 5/2 power plus 9 to the, oh, I don't know why I'm putting plus, 1/2 power. 9, not 9, oh my gosh, threw me off. 9 times x to the 1/2 power. That makes a whole lot more sense. And that's equal to f times g of x. And my domain is still x is greater than or equal to 0. Because the combination of the two domains, the intersection of it, works for addition, subtraction, and multiplication. Division gets further restricted. So for the division, and it's not always g of x, it's whatever the denominator is. And in this case, it's g of x. So g of x cannot equal 0, which means the square root of x cannot equal 0. So x cannot equal what? 0. Right? So this is an additional restriction to what I already have. So I substitute this in, and I get x squared plus 9 divided by the square root of x. Can I cancel those x's out? No. Can I leave it like this? No. What do I have to do? Rationalize the denominator. So I have to multiply by the square root of x over the square root of x. And when you do something like this, remember, you've got to distribute that into both of these. Have we already done that? Isn't that what we just did there? So we already know what we're going to get there, right? And so I know that f over g of x is going to equal, this is my numerator right here, right? X to the 5/2 plus 9 times x to the 1/2. I'm going to move mine down. I can't read it. So I get x to the 5/2 power plus 9 times x to the 1/2 power over what? X. Okay. And then my domain is going to look like what? Good. X is greater than 0. I lose the equals part of that because I just said that it cannot equal 0. Okay. We okay with that? We don't get to include it anymore because this is an additional restriction. Any questions? All right. Next one. What is the domain here? All real numbers. What is the domain here? All real numbers. So this is g plus f of x is going to be x squared minus 4x plus 2x cubed, right? So then that just means that g plus f of x is equal to 2x cubed plus x squared minus 4x. So then what's your domain? All real numbers. F minus g is going to give me 2x cubed minus x squared minus 4x, which means that f minus g of x is equal to 2x cubed minus x squared, then what? Plus 4x. Could I factor something out here? Yes. Do I need to? No. So don't do it. Remember, don't just start doing stuff just because you can. My domain is all real numbers. f times g. So it's going to give me 2x cubed times x squared minus 4x. So f times g of x. 2x cubed times x squared is what? 2x to the 5th minus 8x to the 4th. And my domain is all real numbers. All right, so the quotient, g of x, is the denominator. G of x cannot equal 0. That means that x squared minus 4x cannot equal 0. So how do I figure out what those x's are? Do I add 4x to both sides? I factor. I factor out an x, gives me x minus 4, and that cannot equal 0, which means x cannot equal 0, and x minus 4 cannot equal 0, so x cannot equal 4. There are my two additional restrictions. Okay? Everybody okay with all that? So now I substitute this in. F, which is 2x cubed, over g, which is x squared minus 4x. Can I reduce this? Yes. What do I need to do to the denominator to make that happen? Factor. So 2x cubed over x times x minus 4. Right? So now what am I going to be able to cancel out? An x. Good. So f over g of x is equal to 2x squared over x minus 4. Can I cancel these x's out here? No. If I wait until now to look at my domain, it looks like just x can't equal 4. But I actually have two parts to that. That's why you have to look at it beforehand, because when things cancel out, you lose that. So my domain then is going to be the set of x's such that x cannot equal 0 or 4. Okay. Everybody okay with all that? Yes? Need to be knocking those cobwebs off, because this is all stuff we should have seen in some form or fashion. All right, so the domain here, what do we know about this? Is it all real numbers? No. What can't x be? 0. X cannot be 0, and here x cannot be what? -2. Okay, which means that the combination of those two is my new domain. All right, so then here, f plus g, so I get 1 over x plus 2 over x plus 2. So when I add these, what do I have to have? Common denominators. So if I let you have those calculators, could you find your common denominator on the calculator? Oh, you mean those calculators won't do all fractions for you? There's a reason you need your fraction properties? Oh, wow. We learn something new every day, don't we? All right, so what do I need to multiply this one by to get my common denominator? X plus 2. So x plus 2 over x times x plus 2 plus 2 times x over x times x plus 2. Now, do I have to distribute that x in the denominator? No, it's actually better not to sometimes in case I can reduce something in the end. I just have to factor it right back out. So I can just leave that like that. But I need to combine my numerators, so f plus g of x is equal to 3x plus 2 over x plus, x times x, oh goodness, okay. It's x times x plus 2, but if I write it like that, it's spaced wrong, and my board's not cooperating. X times x plus 2, there you go. Can I cancel those 2's out? No, you can't reduce that any. And so this is my answer, and my domain is set of all x's such that x cannot equal 0 or -2. Okay. Then g minus f is going to be 2 over x plus 2 minus 1 over x. Okay, so does that become 1 over 2 because the x's cancel out the denominator? No. Okay, you gotta have a common denominator, so this becomes 2x over x times x plus 2 minus x plus 2 over x times x plus 2. So g minus f of x equals, I get x times x plus 2 in the denominator. What do I end up with in the numerator? X plus 2, and then I can cancel them out? Yes? Y'all agree with that? Everybody? So every single one of y'all is wrong? Nope, Sean's not wrong. Why not, Sean? Minus what? Uh-huh. Guys, y'all do the hard stuff right. You cannot mess up on things like this. Period. End of story. You subtract the x and you get x, and then minus 2 is negative 2, and there ain't nothing that cancels out. Okay? It's the little things that will throw you off and make everything else you do after that wrong. Okay? That is a very, very basic concept that y'all mess up on a lot. And I say y'all as a lot of y'all. Okay? Even those of you that don't always make a lot of mistakes, that's a mistake that happens a lot. All right, so then my domain is x, the set of all x's such that x cannot equal 0 or negative 2. All right, so then I got to multiply them. G is 2 over x plus 2 times 1 over x. So do I need to get a common denominator? No, you only do that for addition and subtraction. I mean, you can get one here and then they cancel out, but I don't know why the heck you'd want to go through all that. Multiplying fractions is easy. You just multiply straight across, so I get 2 over x squared plus 2x, and that is g times f of x. Okay. Your domain is still the set of all x's such that x cannot equal 0 or negative 2. Then I'm going to divide. So I have to look at my domain again. G of x cannot equal 0, right? That means that 2 over x plus 2 cannot equal 0. So if I multiply both sides by x plus 2, I get 2 cannot equal 0. Does that mean I did something wrong? How many of you would get to this point and then be really confused and think that you have no idea what you're doing, right? Okay, so let me ask you this. When you're up here, is there anything at all that I could substitute in for x to get a 0? No. So if you understand that from the beginning, there's no way for it to be 0. You don't even have to go through this. But most of you don't analyze those things. You just go through the motions of the problem that you did before because you think everything's identical and it's totally not. And then you don't know what to do when you get to something like this. What this means is I can't let in this function, I can't let 2 equal 0. Is 2 ever going to equal 0? No, then we're fine, right? We don't add anything to it. We're good. 2, 1, in my universe, 2 is not going to equal 0. And so this is a valid thing for you to get. You're concerned with adding restrictions. The only restriction you have to add is one that doesn't even make any sense, so it doesn't matter, because you can't get 0 from that because there's not a variable in the numerator. Does that make sense to you? Okay, so I'm good. It's going to be the same domain. But then I substituted in f of x is 1 over x over g of x, which is 2 over x plus 2. So dividing fractions is easy, right? 1 over x times x plus 2 over 2. So that means that f over g of x is equal to x plus 2 over 2x. Can I cancel out the 2 and cancel out the x? No, because then I will cancel you out. No. The domain is the set of all x's such that x cannot equal 0 or negative 2. Are we good? Any questions? We good? All right. Next one. So, here. What's my domain? All right. Well, let me ask you this, because I know you can figure that out too. But these are square roots, right? If I was to graph the parent function looks like this, right? It's the teapot. All right. So this one, if I was to graph it, all it is this, and what do you do with this? Move it to the left 6. So it looks like this, right? So can you easily see what your domain is then? Yes. Here, all you would do with this one is do what with it? Move it to the right 2, right? So it looks like this. Yes? So here, your x's have to be greater than or equal to -6. And here, your x's have to be greater than or equal to 2. Does that make sense? So you can think of it visually, and all those different ways you should be able to kind of process through them. All right. So we go to substitute this in, and I get the square root of x minus 2 plus the square root of x plus 6, right? Can I combine those and get 2x plus 4? No. Okay, totally cannot. There's nothing I can do. That's as good as it gets, and that is g plus f of x. Now we've got to look at the domain. The domain for a, b, and c are going to be the same, right? But the domain is the intersection. So the intersection is what both domains have in common. So am I going to say that x has to be greater than or equal to -6 and x has to be greater than or equal to 2? No, I'm just going to say what? Greater than or equal to 2. Because this set right here is inside of this one. This has some extra stuff that this one doesn't, so it's not part of the intersection. So my domain, oh, I boxed too soon. My domain is x has to be greater than or equal to 2. Just add that in there. So then I've got f, which is the square root of x plus 6, minus g, which is the square root of x minus 2. And can I combine that at all? Nope. Do I distribute that negative in here? No, you can't do any of that. So that's equal to f minus g of x. And my domain is still x is greater than or equal to 2. We good? Now I'm going to multiply g of x, which is the square root of x minus 2, times the square root of x plus 6. Can I combine this? Yes. When you're multiplying and dividing, you totally can. So this is the square root of x minus 2 times x plus 6. So g times f of x equals the square root, and we can multiply that out, so we get x squared, and then plus 6x minus 2x, so that's plus 4x, and then minus 12. Can I take the square root of this x squared and just make that x now? No. Can I take the square root of the 4? Can I simplify this at all? No. Don't go start making up math. Your domain is still x is greater than or equal to 2. So now I have to look at my denominator. So g of x cannot equal 0. The square root of x minus 2 cannot equal 0. Therefore, x minus 2 cannot equal 0. So x cannot equal 2. This is an additional restriction. Or is it? Is this going to make my domain different than what it's been? Yes, because I was able to include 2. Now they're saying, nope, you don't get to include 2 anymore. So then I get this, and I've got f, which is the square root of x plus 6, divided by the square root of x minus 2. Can I cancel the x's out? Can I divide 6 and 2 and get 3? No. Can I leave it like this? No. What do I have to do? Rationalize the denominator. So I multiply by the square root of x minus 2 over the square root of x minus 2. Have I already multiplied these two things together? Yeah, I just did it right there, right? So that gives me the square root, again, of x squared plus 4x minus 12. What do I get in the denominator? X minus 2. Can I reduce anything? No. If there was a 2 here, could I reduce every single term by 2 then? No. These live in two different worlds. You can't do any of that stuff. That's equal to f over g of x. And so my domain now is what? X is greater than 2. Good. Very good. Uh-huh. No, because we're just trying to get rid of the square root. Does that make sense? Okay, yeah. I see why you're thinking that, because you had done that in some other things, but not in this situation, no. Okay, that's a good question. All right, we good? Any questions? You would simplify it. Yes. You always simplify if you can. We just can't here. And the things I was asking you, can we do this, can we do that, those would be illegal simplifications that I see a lot. But yes, you simplify if you can. That's a good question. Anything else? Okay. All right. So now we're going to find, we're given f of x and g of x, and we're going to evaluate each function. Now, we could go ahead and find the function combined and then substitute, but you don't have to. You can substitute and then combine. That's why you get to write it 2 different ways. So I'm going to substitute in this 5. And that's going to give me, for f of x, 4 minus 5 squared plus the g of x, which is 2 times 5 plus 8, right? This should be a piece of cake. So that gives me 4 minus 25 plus 10 plus 8. And if it were me, I would not just go from left to right here. I'd do all my positives. So I've got 10 and 8 is 18 and 4 is 22. So 22 and a negative 25 is what? Negative 3. There we go. Then f times g, that's going to be 4 minus a negative 2 squared times g, which is 2 times a negative 2 plus 8. So this gives me 4 minus 4 times negative 4 plus 8. But honestly, once we get to this point, does it even matter what else is happening? No, because what's 4 minus 4? 0. And you multiply by 0, it just doesn't even matter. So f times g of negative 2 equals 0. We good? Any questions at all? All right, good deal. So remember, when I give you the assignment, front only. Don't even look at the back, even though you might be able to do it 100% right now, okay? Don't even look at it. I'll know. All right.